Okay, so today we're going to be using grids to find probabilities and compound probabilities, sections 14F and 14G from the textbook. So we're going to be talking about independent events, and these are two different events where the outcome of one does not affect the outcome of the other. Okay, so in this case we have two bags. One has 2 green marbles and 1 yellow marble. The second bag has 2 red marbles and 2 blue marbles. So a marble is randomly selected from each bag. So we want to know the probability of getting a green from the first and a blue from the second. So we're going to use grids to set this up. Alright, so in this case we have 2 green and 1 yellow, so that's going to be 3. Okay, and then we have 2 blue and 2 red, so that's going to be 4. So we got 1, 2, 3. Okay, this is the first bag here. We have 2 green, 1 yellow. Green, green, yellow. And then here we have 4. We have 2 red, 2 blue. Red, red, blue, blue. So again, we fill in these dots to give us a representation of how many options we have. So you can see that it's 4 by 3, so there's 12 different possibilities, right? 4 by 3, 12 different possibilities. So what's the probability of getting a green marble from the first bag and a blue marble from the second? Well, here's green marbles, here's blue marbles. So this is a green marble and a blue marble. This is a green marble and a blue marble, as is this, and as is this. So really, it's these 4 out of the 12 that are the correct answer. So we have 4 out of 12. Now again, in IB Math studies, 4 over 12 is an acceptable answer. You can simplify that. That's of course 4 times 1 over 4 times 3, which is 1/3. Either one of those is an acceptable answer. Okay. Now you may be thinking, do I really have to draw this grid every time to do the simple problem? Of course not. This is just a way to represent it. So we're going to now move on to compound probabilities and solve the same problem using what's called compound probabilities, where we don't have to draw a picture. Alright, so if you think of it this way, we have 2 green marbles and 1 yellow marble in bag 1. Okay, so this is compound probability over here. So that's 2 green out of 3, right, for bag number 1. For bag number 2, we want a blue marble, and we have 2 blue marbles. So we have 2 blue out of 4. Okay, and we know our answer is 4 over 12. Right? We know what the answer is because we drew it over here. What do you think we need to do with these fractions to get 4 over 12? Do you see it? You see what we need to do? Yeah, you can see that we just need to multiply them, right? 2 times 2 is 4. 3 times 4 is 12. And again, we can represent that as 1 over 3. But either one is acceptable. So that's what's called compound probabilities. Okay, so when we have 2 independent events, in other words, they don't depend on each other, the outcome of one doesn't affect the other, then you just multiply those 2 probabilities to get the final probability of both of those things happening. Alright, another way to write that, I'm just going to scroll down here a little bit. A way to write that would be the probability, you know what, I'm going to do it over here. Let's see. The probability of A and the probability of B, assuming they're independent, is equal to the probability of A times B. Okay, A times B. Right? So that's how we write that. No, that's really not how we write it, actually. Now I'm looking down, there's slightly different. Whoop. Let's write it like this. The probability of A and B is equal to the probability of A times the probability of B. That's the better way to write it. Okay, so just a little bit of notation, how we write things down there. Now I think you're ready for a practice problem, so I want you to read this practice problem and see if you can figure out how to do it. Go ahead and pause and read this one and solve it. Okay, so you're back. We have 7 chocolate donuts, 11 glazed donuts, 2 raspberry cream. So that's a total of 7 plus 11 is 18, plus 2 is 20. All right? So here's the idea. Steve reaches in. What's the probability to get it glazed? Well, there's 11. So it's 11 out of 20. He puts it back. Kind of gross, but he does. So then there's still the same number the second time. It's a completely new situation with the same numbers. Again, he gets a glazed donut the second time. There's still 11 left in there because he put it back. So what's 11 over 20? First event, second event. What do? We multiply them. So we have 121 over 400. And that is, in fact, our answer. Okay? Now, moving on, we talked about independent events. Of course, we're going to talk about dependent events. Okay? This is a situation where there's 2 events and the outcome of one affects the outcome of the other. So in this example, we have a box which has 5 purple tickets and 7 black tickets. 2 tickets are randomly selected without replacement. What's the probability that they're both purple? So, in the first situation, we have 5 purple tickets out of a total of 12. So, there's the first draw, right? That's 5 out of 12. But we also have without replacement. So that means that after you get the first purple, you don't put it back. So for the second draw, we're drawing tickets out of a box. The second draw, how many tickets are there left? Think about that. Yeah, there's only 11. And how many of them are purple? There's only 4 left that are purple because you already drew one that's purple here. Okay, so we have 2 events, and again, we just multiply these, but you have to take these numbers, the first draw, into account when figuring out what these numbers are. Again, we multiply them, so in this case, we have 20 over, what is that, 132, which again is a fine answer in IB Math Studies. You can simplify that, but you don't have to, so let's not. Okay? So you're going to practice one of these dependent events right now. There are 20 Bao steamed buns in a box. 7 of them have barbecued pork inside. If you grab 2 of them, what's the probability that you have 1 barbecue pork bun and 1 that is not? Go ahead and pause this and give it a shot. Alrighty, so we're going to take a look. The key here is that they're dependent events. Grabbing 2 at the same time is the same thing as grabbing 1 and then grabbing the next without replacement. So, it could be that you get a barbecue and then not, right? So the chance of getting a barbecue first is 7 out of 20. And not, well, you already grabbed one, so it's only at a 19. How many are not barbecue? Well, you didn't grab one that was barbecue, so there's still 13 left. So you're going to multiply that, right? But that's not all, because there's another situation. We could also get not and then barbecue, right? And if you get the one that's not first and then the barbecue, it doesn't say, it says and here. Okay, it doesn't matter which order we do it in. So, in other words, we need to have 2 different situations. The not is 13 over 20. And the barbecue, there's still 7 left, and that's 7 over 19. Now you'll notice here, even though these are different fractions, they end up being the same thing. 7 times 13 over 20 times 19, right? And this is 13 times 7 over 20 times 19. These end up being the same numbers. I'm not going to do the multiplication, but you get the idea. So it ends up being 2 times 7 times 13 over 20 times 19. And that's how we do it. All right? Thank you for listening. Toodles.